Yeah. Well, it can be. Yeah, that's that's the mean of the sample distribution. Your sample distribution can be SPRAC data. Yeah.
Hey, Jared.
Onion. Did you make a calculator? I really choosy one. Me too. It's not like good. It's just like the one equation that we did it very well. That's all. Yeah, see, I didn't even get very many.
Hey, Jared. How's it going?
Oh, good. How you doing?
Not too shabby.
Nice, nice.
Oh, see.
Get these other guys on. Looks like Zach is not jumping on the call tonight.
Hasn't been working for tap water's just fine for me.
Better than California water, I feel like.
Yeah. Well, I don't know.
Just that the minerals are still in it. I just remember being like having almost like a muddy taste to it. And here's what it was. Well, I mean,
I need to mute my mic. That's why. Just to my mic out of your computer and back to my mic. I was like, wait, I thought we fixed it.
Hey, guys. How's everything going tonight?
Come
on.
Are we ready?
Yeah.
I guess so.
Cool. Let's jump into it. So we're on lesson 6, right?
Mm-hmm.
So we start with the homework. I guess that's what we always do, huh? By the way, we are recording.
Oh, good.
Just thought I'd throw that out there.
Actually, wasn't asked, but then I even forgot to do that.
Well, make sure you try to remember, because I'll probably forget next week. All right, so number 1, what is the sampling distribution? Sampling distribution is all of the sample means from a population. I guess there's only one sample mean from the study, but there could be a lot of different ones from the within the population.
Each study of the same subject is just another block to the puzzle, or block to the graph. And the sampling distribution is just all of the studies that are possibly done.
Makes sense.
Yeah.
Okay. All right.
What is the shape of the sampling distribution of the sample mean when the data are normally distributed? The shape is normal. Normal.
Wow.
Normally distributed would look normal.
That's a hard one.
You got by just barely.
Yeah. Okay. All right. I could read the next one.
What is the?
All right, cool.
Oh, good. What is the shape of the sampling distribution of the sample mean when the data are not normally distributed but the sample size is large, and that is approximately normal.
Yeah.
Which makes sense after reading the large number stuff. So.
Yeah. And is that an example of that's not the large number rule? What's the other rule?
No, that's the central limit theorem.
Yeah.
We'll get that to number 5.
Yeah, okay. All right, anyway, go ahead.
I'll read the next one.
Okay.
How does the shape of the sampling distribution of the sample mean change when the sample size is increased? From what I noticed, pretty much just gets like tighter and gets more like compact inside like one little shorter bell curve. So it doesn't really doesn't get wider or anything. It kind of shrinks up.
Yeah. Kind of compresses because the standard deviation is shrinking up.
Mm-hmm.
Okay. All right, Jared, you want to take number 5?
Oh, yeah. What is the difference between the central limit theorem and the law of large numbers? Well, the central limit theorem simply states that a large sample size will give you an approximately normal distribution, and the law of large numbers says that the larger your sample size, the smaller your standard deviation gets.
Okay. Does that make sense to everybody? I was a little confused on that at first. Seemed like it was saying the same thing, but it's not.
Well, the central limit theorem just kind of states like a fact, I guess, whereas the law of large numbers kind of like tells you a little bit more about a concept rather than just a fact.
Yeah, that makes sense. It emphasizes a trend. Okay. When is X bar normally distributed? The X bar is normally distributed if it comes from a normal population, or if it has a big sample size.
Yeah, for this class, that would be equal to or greater than 30, right?
Yes.
Did you guys select all the little random samples?
No, I didn't print those off. Did you guys?
No. I highlighted them.
Yeah.
I just wrote them down on my Excel sheet.
Yeah, I just wrote them down. So it looks like part 2 is this activity. Do we want to go through that? You guys have questions about that? So we just read through it.
Yeah, we can just read through it.
Yeah.
Okay, I'll summarize what the directions kind of were. As I said, use this random number generator to generate numbers 1 through 30, and 5 of them. And then select out of those 5, you coordinated it with the values in the chart. And you took the values and you found the means of them, and you also found let's see. So you found the means of your sample, and then you charted it on your graph, the graph down there.
Yeah.
Which one? Mine ended up being 46,600. And then, so that's pretty close to right smack down in the middle.
Okay.
And then, see, does your sample mean appear to be unusual? Explain why you think this is or is not. My numbers are pretty diverse, so I got a really even mean to it all, even though they're random. I think that it's pretty usual.
Yeah, I think. Does anybody have any questions about that? I mean, basically, we're just running a simulation a little bit there.
Well, it seemed approximately normal to me.
Yeah. Should we move on to 8?
Yeah. Compare your mean in question 7A to the means obtained by at least 3 other individuals. Oh, I had mine. Mine was 45,900. Yeah, it's kind of like a little to the left of the mean, but or on the top of the curve, but it's approximately, but it's still pretty usual. I mean, it's not like 40,000 or anything weird like that.
Right. And mine was 46,400. So
That's
we're all
perfect.
kind of in the
Yeah.
right in the middle there.
The graduate management admission test is used as an admission criterion in many master's or business administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Alright. Consider a simple random sample of 10 students taking GMAT. Calculator. You got the, oh, you already did it? Calculation for it? Uh-huh. Yeah. There's like 529 for mean and deviation 113. Sample of 10. And what is the shape of the distribution of the sample mean for all such samples? So, huh? Bell curve?
Should be normally the normal distribution.
Well, it's going to be normal. Is that what they're looking for? Is it normal or approximately normal? Yeah, normal. Ha! You got that.
Yeah, like,
Well, they said it
because
was
it's like, it's the mean of your mean movement.
well, it said it's normally distributed. If it wasn't normally distributed, or if it was approximately normally distributed, then you'd say, well, how did they say it? They said, yeah, oh, okay. It's either normally distributed or it's not normally distributed. And when it's not, if it has a large enough sample size, then it's approximately normal. But since this one says it's normally distributed, then it's normal. So,
And it's normal because the parent population is normal, correct?
Mhm.
Yep.
That's like, I think that's that. So parent mean is normal, so the mean of the sample distribution is normal.
Yeah, so that's 529, right?
so if my child is normal, then the parent must be normal, right?
Right.
Oh, approximately.
Or if the child is approximately normal, then I'm definitely not normal.
All right, so D then is the standard deviation, and the standard deviation is the let's see, this standard deviation of the sampling is 113, right? And to get this, no, wait, I said that backwards.
So confusing. I think
Yeah, we're trying to get the sample medians for the group, right? So we take the standard deviation divided by the square root of the sample size.
or
Okay. Yeah.
So 113 divided by the square root of 10.
yeah.
35.7.
Yep.
Done.
Which is really interesting because what from looking at this, like, you can find the sample deviation without ever knowing what the sample size was or the sample mean or anything.
Hmm.
You still need the deviation. It's just
You just
can
need the deviation. That's all. You don't need the mean or the sample size.
screw mean.
Or no, you need the. You don't need the population size. You just need the sample size.
Oh yeah.
The sample of your population.
All right. Should we move on to the quiz?
Do it.
All right.
Did anyone email the teacher about the last quiz with that dumb three decimal point thing?
Oh yeah, I didn't email her about that. Did any of you?
No, I thought someone would. I kind of thought that everybody would, so I didn't. I was going to just keep my mouth shut.
We pulled a Kitty Genovese on us here. Everybody thought everybody else was going to do it.
It's okay. I still get May, so I'm not going to cry yet. Okay, when taking samples of n, when n equals 5, what was the shape of... Oh, this is based on the homework? So what was the shape of the homework question?
Parent population is right skewed.
What? Okay, what was
Wait,
the shape of the distribution of means histogram when the parent population is right skewed? Oh,
When n is 5, then it is slightly skewed. And then the population
Yeah. So it's a small sample, so it would still be right skewed. Is that correct?
this n equals 5. N equals 5. Alright. N equals 5, and then you can do as many as you want.
that's totally right skewed.
Well, is it?
Yeah.
It's like over there. And you can see the main cache. Yeah.
At least that's what I feel like I got from you.
I thought it was still like pretty much. Well,
See, the next question where it says the sample of 100 and right skewed, then it's going to be normal.
So we have
okay.
skewed right for number 3 and normal for number 4.
I'm reading the comment. Button 3 there. So right, that right here. So when you change it from 5 to the. Yeah, we're still on the. I'm looking for. There it is, right?
Hey Jared, do you mind sharing your screen?
Oh yeah. Sorry, it's gonna be kind of sporadic. So.
Oh, is it? Okay. All right. Well,
don't strain your eyes too bad. Press forward and use the drop down menu below. Change it to right skewed. So this person, that's right skewed. What do you notice about the shape? No, I mean, like, it kind of seems like a bell curve to me. And I mean,
Yeah.
like, if I do
Yeah.
normal, then I do 10,000. Well, it's like just, it's like barely. Yeah, I guess it is right skewed. I'm not gonna complain. I think right skewed.
I'll turn on in person.
Cheaters. I don't know. I mean, like, I want to say it's normal, but I mean, I see that. I mean, everyone sees this thing, right?
right.
Yeah.
Okay. Well, if it's normal, then I'm going to tell her to watch the video. Look at it. Okay.
Okay. So then 4 is the sample size of n of 100. So this should be normal because of the large sample size, right?
Yeah. the sample goes from 5 to 100, it should be more normal.
And the sample size 25 even. Out of 25? Yeah, even 25. Maybe like, yeah, it's more normal.
Yeah.
Yeah. And same with the next one, which is we're taking a sample, taking samples of n on 100, the sample, or the shape of the normal distribution means, or normally distributed one is normal.
This one would be normal. Yeah.
Probably normal.
Okay.
When would the distribution of means be normally distributed? Choose all correct responses.
So the
First one, right?
yeah. Does your first one read data are
Oh,
drawn?
right. It's different for everyone.
Yeah.
I think
Data are-
both of them that end with large.
Yeah. So I have data are drawn from a population that is normally distributed and the sample size is small. So that one would be correct, right?
Yeah, that's true as well. I forgot about that. So it would be 3 correct answers.
So it's going to be both the normally distributed ones and then the one that says right skewed with a large sample
Large
size.
sample. Okay, got it.
All right. So, which of the following gives the best explanation of the central limit theorem?
One that has the most.
If the sampling size is large, the shape of the sampling distribution of the sample mean x will be approximately normal.
It's like word for word, isn't it?
Sounds like it. Yeah, I don't like the other ones anyway, so that one looks the best.
Yeah.
Wait, what about if the parent population is normally distributed, then the sample mean x will follow a normal distribution?
Is that central limit theorem?
Uh,
Well, let's see. Do we?
The central limit theorem states that if sample size is large, the sample mean will be approximately normally distributed. Yeah,
That's like word for word.
I think we have it right. Uh-huh. Yep, that's it.
That's the. Sorry, which one did we choose? The sample is large.
The first one we chose.
Yeah.
If the sample size is large, the shape of the sampling distribution of the same mean will be approximately normal.
Okay. All right, that was the bottom one for mine. Okay. All right. That's what I had. Let x be a random variable with a population mean of mu of 10 and a population standard deviation of 6. Suppose a sample size of n equals 36 is drawn from the population. What is the mean distribution of sample means?
I got 1. What did you get?
So there was something that I talked about that if the population size is, if the sample size is greater than the standard deviation.
Well, if the sample size is greater than the mean, what happened?
If the standard deviation is greater than the sample mean, then you're supposed to, or the sample size.
So it's asking what is the mean of the distribution of sample means? Oh, okay. So that would be the number we calculate. I got 1. Maybe I need to.
So,
36 sorry. 1.
Oh, you got 1? Okay.
Yeah.
Because I could have sworn I had decimals. Okay. 1.
3 decimals or 2?
It doesn't say.
Hopefully. Next one says 3.
So what did we come up with on that? That's the
1.
yeah, because it's 6 divided by the square root of 36, right?
What is the standard deviation of the distribution?
Oh, well, 6 times 6 is 36. 6 divided by 6 is 1. So I would guess it'd just be 1, not like 1.00 or anything. What is the standard
wait.
deviation?
Distribution of continuous?
Hold on a sec, guys. The mean of the sample means is mu, and the standard deviation of the sample means. So the mean of the sample means.
Oh yeah, because it's asking for the next one coming 1.
0.000 because it wants to be decimal.
Because that's what we calculated the distribution of sample means.
Mhm.
And now it's just asking for the sample. What is the mean of the sample?
Yep.
Use screen sharing yours.
Mhm.
So we have 10 for number 8.
Yep.
And 1.00 for number 9.
1.000.
Yeah.
Oh yeah,
And then
because it's 3
we've got that
decimals.
one. Yeah, standard deviation divided by the square root
Of
the
n of the sample size.
Regardless of the distribution of the population, if the sample size is larger than 30, what would be the shape? Distribution would be normal, right?
Yeah.
Yeah.
Approximately. What theorem would justify your response?
That's the
That would be
law.
central, right?
Central
The
limit
law
theorem.
of large numbers is that the larger the number, the closer you'll be to the actual population mean.
Well, the law of large numbers is the larger the sample size you have, the smaller your standard deviation of the distribution of sample means.
Which means, okay. I thought I had to do something.
You know,
You got closer to the actual mean of the sample for the population.
it's
yeah.
the one that like tucks in the sides of the graph, makes it more clean.
Yeah.
The bell curve.
Okay.
So
saying
that
central and
central limit theorem, right?
So I guess okay to submit this.
Ready to submit?
Okay, wait, 100%. Yeah. So, yeah, okay.
yay.
Cool.
Nice. Cool.
Good thing you caught us on that. And the brain then.
Yeah.
Yeah.
That one was. All right, guys. Well, anything else?
Keep sending me that link.
Will do.
Awesome. Thanks, guys.
All right. Thanks,
Cool.
everybody. Have a good night.
See ya.